Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 873, length of longest Fibonacci subsequence. This question is based out of dynamic programming and it is recently asked in Adobe interviews. Let's have a look on the problem statement. Here they are saying that Fibonacci sequence is something like a sequence of length greater than or equal to 3, at least 3 elements A, B, C. Then third element or maybe any ith element is the sum of the previous two elements. Let's say if first two elements are like this, third element should be 3, sum of previous two elements, and fourth element is sum of previous two elements, which is 5. So this is a Fibonacci sequence. And what is given to us? We are given a strictly increasing array ARR of positive integer forming a sequence. See, this is given to us an array of elements which are strictly increasing in nature, and we have to return the length of longest Fibonacci like subsequence of array. If it does not exist, return 0. This is nothing, just a definition of subsequence. Okay, now let's try to understand with the help of an example. Here what is given to us? We are given an array of positive integer strictly increasing in nature. What we have to figure out is Fibonacci subsequence which is longest in length. And see, first of all, let's focus on this term subsequence. Subsequence, what is that? Subsequence is like when if I just remove couple of elements from this array. Let's say I am removing this 2, 3, 7, 11. It is a subsequence. If I do not remove any element, the whole array itself is a subsequence. Or let's say when I'm doing the iteration, I am picking this element, skipping it, picking it, skipping it, picking it. So all the picked up elements are subsequence. In short, if I just remove couple of elements from the array, the remaining array in the specific order are forming a subsequence. So this is clear to us. Longest in length. Another one is Fibonacci. So whatever subsequence we are picking, let's say if I pick 3, 4, and 7. This is length is greater than or equal to 3. First condition is satisfied. Second one is every element should be equal to the previous two elements. So only this element we can compare. 7 is the sum of the previous two elements. 4 plus 3 is equal to 7. Correct. So this is a valid Fibonacci subsequence. And the length of this subsequence is 3. But if I try to have a look on this subsequence 3, 4, 7, 11. 3, 4, 7, 11. Sum of 3 and 4 is 7. Sum of 4 and 7 is 11. It means this is also a valid subsequence that we are looking. It's a Fibonacci subsequence of length which is 4. I cannot find any other subsequence of length more than 4. So in this case, 4 is going to be my answer. So this is our problem statement that we have to do. Now let's try to see how we are going to solve this problem. See, you are already aware that it's a dynamic programming problem. And let me give you some tips that for every dynamic programming problem, we have to follow these 4 instructions. Firstly, we have to build the intuition. Secondly, we should be able to think of recursion with memorization. Third one is implementing top-down approach. Fourth one, implementing bottom-up approach. See, whatever is your style of doing dynamic programming problems, these 2 steps are mandatory. After that, if you are comfortable with top-down, you can go for it. Otherwise, if you want to skip it, you directly implement bottom-up approach, even in the interviews. So before jumping to the solution, you have to explain these 2 things to the interviewer. So if you are giving Google interviews and then directly jumping on the bottom-up approach, straightforwardly giving the solution, that is not going to work. Okay, now let's see. Let's try to analyze how we are going to solve. Let's assume that we are going to use the dynamic programming. If it is a dynamic programming question, it should be able to have recursive thinking in the solution. And recursive thinking is being applied there where we have one problem and the subproblem is also there, and the problem and subproblem is of the same nature, right? If problem and subproblem is of the same nature, we can apply recursion in that. But here we are already only given this array. This array where the elements are strictly increasing in nature, and we have to just pick couple of items out of it, and those items should be forming a Fibonacci subsequence. Got it? So here, by just directly looking at the array, I'm not able to figure out what is the problem or what is the problem. So now firstly, let's see what is the Fibonacci subsequence. To be able to have a valid subsequence, we should have 3 elements with us. 3 elements with us, and the third element we are going to decide it will be equal to the sum of previous 2 elements. And in this way, we can move forward with our solution. Okay. Let's try to analyze what is the problem and subproblem in this case. See, directly we are not able to see. We'll try to utilize the concept of Fibonacci. Fibonacci is something we are having to, let's say you are picking one number, picking 2. Okay. 2 is not a Fibonacci subsequence because its length is less than 3. And let's say you are now picking 3. This is also not a Fibonacci subsequence. And when you are picking 4, you have to be deciding that on the basis of previous 2 elements. Previous 2 elements means this and this. So whatever is the second portion is dependent on the previous 2 elements in the current elements which we have picked. Okay. So in this case, starting with 4, we can't have any subsequence. And or in other terms, if I say that I can only place a subsequence after 2 and 3 if that subsequence is starting from 3 plus 2, which is 5. It means that sequence should be valid sequence that we can put after 2 and 3. Okay. So this subsection is dependent on these 2 values. Let's try to understand using some other values as well. Let's say we have picked 3 and 4. 3 and 4 are 2 values. These 2 values we can pick in any order. They are not dependent. First value you can pick any value. Second value you can pick any value. But remember that you are picking I and you are picking J. J should be greater than I. It should not like that 4 and 3 you are picking, because those are increasing in nature and we are comfortable picking these values. See, once we have picked these values, our problem reduces to that we have to find a longest Fibonacci subsequence. Longest Fibonacci subsequence starting with 7, or in other terms, that can fit after 3 and 4. That can fit after 3 and 4. So longest Fibonacci subsequence that can fit after 3 and 4. In this case, if I just try to get the answer, see, let's say we have picked 3 in the starting. No, nothing to worry about. Just pick it. Just pick the 4, pick the 7, anything. And now after this, my sub problem will be reduced to something like find the longest Fibonacci subsequence that can fit after these 2. It means this subsequence will be dependent on these 2 values, right? And this subsequence is starting from what index? Index of 4, 0, 1, 2, 2 plus 1, starting from index 3. So starting from index 3, find a subsequence that can fit after this value. Okay. If I just try to find a subsequence, find a subsequence after index 3 from this array. It means find a subsequence from array 7 and 11 which can fit after 3. If I just try to fit 7 after it, I need to make sure that 7 is sum of the previous 2 elements. Previous 2 elements are, this is the previous one and this is previous to previous if this is the current one. So current is equal to previous plus previous of previous. In this case, yeah, I can easily put 7 here, 7 here. So if I just zoom out this subproblem, this subproblem will look like something like this: 3, 4, 7, and now starting from index 3, 2, 3, 4. Starting from index 4, find the longest Fibonacci subsequence that can fit after this value, fit after these values, or fit after 4 or 7. So the remaining array is 11 in this case. It means I have to fit 11 after it. I will see whether 11 is the sum of previous and previous to previous. So this, if 11 is my current, previous is 7 and previous to previous is 4. So this condition is true and I can easily put 11 here. And now what is my next sub problem? Next sub problem is something like this: 3, 4, 7, 11, and this is something, find the longest Fibonacci subsequence starting from index 5. Starting from index 5. Index 5 is like size of this array. Index 5. Index 5 means no array is there. If no array is there, the length it is going to give is 0, or the array, that is nothing. So this is my subsequence, maximum subsequence. So in this way we have to start exploring all the possibilities. See here, what I did is, where I started is, I started with two values with us. Two values with me. 2, 3, 4, 7, 11. 2, 3, 4, 7, 11. If I have to start with those two values, and I have to find this sub problem, where this sub problem is the longest Fibonacci subsequence that can fit after these two. How do I pick these two indices? Let's say this is I, this is j. I will pick it accordingly. And this is something j plus 1. Starting j plus 1 till end, I can pick my current element. This is the intuition behind this approach, behind this solution. This is the recursive thinking that we have to do. So in this case, the j will work as previous element. I will work as previous to previous element. And this iteration will work as my current element. Okay. So in this case, if I just try to implement the solution, it will something look like this. Initialize I with this value and j with this value starting from here to here. J can be anything. Let's say if I am just starting with 2, what should be the value at the second position? Second position can have anything. I can place 3, I can place 4, anything. So if anything I can place, I will do something like this. I will start from 0, I will go till n, and for the second element will start from I plus 1. I plus 1. Second element started with I plus 1, and second element will also go till n. So now inside this for loop, what I am going to have is, I have 2 with all the other elements after this, 3 with all the elements after this, 4 with all the elements after this, and 7 with all the elements after this. Okay, so this is my you can say structure where I am going to start my problems. And my problem is something that you have to solve this problem, and this problem is dependent on these two values. Okay, these two values, you can say previous and previous to previous. What is previous and previous to previous? This I and j. I is my previous to previous, j is my previous, and what else? This index is j plus 1. J plus 1. So now this is my solution. And what this solution is going to give me? This is going to give me the longest Fibonacci subsequence that I can attach after this ij. After this ij. And ij are 2 in number. So 2 plus this value is one candidate for my answer. So let's say this is the longest equal to this. So I just have to find the maximum out of it. So how do I find it? Maximum of answer, comma, this value, and after all of these two loops, I can return my maximum and initialize maximum with 0. So this is something we have to do. And in this solution, I'm just passing j and I. See, j and I are passing. If I'm passing j plus I can automatically find. So using j and I can get my answer. Now in this case, we just have to implement the solution function with these two parameters, and this is going to return integer, right? if we are implementing this, we are having two parameters which are variable in number, and we are getting one value. Two parameters will go from 0 to n. In the n square time, we can reduce this recursion by applying the memorization. Okay, so this tabulation will work in order of n square time. And what about the space? We are not utilizing any extra space. In this case, whatever is the recursion stack, that is going to be my space. So this is how the recursion with memorization with tabulation going to work. And now let's also have a look on the bottom up approach. I will drop the code for both the approaches in the description below, so you can have a look on that. Now let's see what is going to be the bottom up for this. 2, 3, 4, 7, 11. 2, 3, 4, 7, 11. Bottom up is something opposite of top down approach. In the top down approach, I first discussed about P. What is the biggest problem? P is my biggest problem, and then sub problem, one smaller than that. And what is the edge case? When there is no element in the array left, or maybe index is equal to n, then the length of longest Fibonacci subsequence is 0. This is my smallest problem. So from top to bottom we are going in top down, and in the bottom up we will try to start with smallest problem first. Let's try to have a look on the bottom up approach. See, if I just ask you, if my array is empty, then the length of the longest Fibonacci subsequence is 0. If it is only one element, you can say the length is 1, but as we require length is greater than 2, so you can say, if let's say one element is 2, you can say it is 1 or 0 depending on your choice. One element means I and j are equal, and more than one element means the value of j is greater than I. Correct? So value of j is greater than I. It means ending with I and j. What is the length of subsequence, longest Fibonacci subsequence ending at I and j? So if I just take I as 2, j as 3, what is the length of longest subsequence ending at index 0 and 1? If j is at 4, what is the length of Fibonacci subsequence ending at 2, 0 and 2 index? Right? In the end, if I just directly show you the answer, the length of longest subsequence ending at 7 and 4, that is 3, 4, 7, 11. That will be 4 in our DP. Right? So what is the value of I and j? Before that, what we have to figure out? We have to figure out this DP of I and j. The length of longest Fibonacci subsequence ending at index element at index I, element at index j. And the I value will go from 0 to n minus 1. J value will go from 0 to n minus 1. So DP size is n cross n. Correct? So if I just draw the tabulation and try to fill, let's see, let's try to drive the formula. 2, 3, 4, 7, 11. If I want to find a subsequence which is longest Fibonacci subsequence ending at I and j. Let's say in this case, see, j value is 1. So I value will go from 0 to less than j. That is 0. So I have only one possibility, 0. It means if I want to use I and j, it means if I want to use 2 and 3 as the last two elements of my subsequence, I firstly try to see what is the longest subsequence ending at 2 and any of the previous element, right? Any of the previous element, and previous element should be in accordance with 3. It means sum of this value and this value should be equal to j. This is I, this is j, this is, you can say, previous to previous if it is current, if it is previous, right? And what will the value of previous to previous? That is equal to value at j minus value at I will be here. Correct? So 3 minus 2 is 1. I will try to see whether there is any element, whether 2 is making any longest subsequence with 1. See, 1 is not in this array, so there is not an option. If 1 is not there, we can directly say that okay, the answer will be 2, because 2 is not going to make any subsequence with anyone. You will understand it once we fill the table step by step. Okay, now what I will try to do is I will consider my j equal to 2. J equal to 2. It means my j value is 4. And what can be the possible value of I? Possible value of I can be 2 and 3. Firstly, let's try to understand 2. If I try to finish the longest Fibonacci subsequence with 2 and 4, I will see what was the Fibonacci subsequence ending at 2. That is nothing. Okay. For that, how we can figure out? We can figure out this value, and this value is 4 minus 2, which is 2. Was the 2 present initially before 2? No. So if that is not the case, you can consider these two elements. These two elements will be placed here. Okay. Now in the second go, my j is at 2 and I was 0, I was 1. If I was 1, it means 3 and 4. Now I will try to see whether 3, 4 can make any better subsequence. So what was the longest subsequence so far ending at 3? Ending at 3, let's say this is the longest subsequence ending at 3, and see, in this case if I have to attach 4, what will be the value at this? 4 minus 3, which is 1. So it means we have to find the subsequence which is ending with 1 and 3, and there is no subsequence like this because 1 is not in the array. If 1 is not in the array, just place 2. Why 2? 3 and 4 we are considering as the subsequence. It is not valid. For that we can apply condition while we are returning the answer, but for now let's consider 2. Okay. Now as a next step, my j value is at 7. My j value is at index 3, which is 7, having a value of 7. Now if I equal to 0, my subsequence is ending at 2 and 7. It means that the previous value should be 7 minus 2. Which is 5. See, this is not at all possible because in this case elements are increasing in nature. If elements are increasing in nature, this is not possible, correct? So in this case only 2 and 7 can form a subsequence. What about 7 and 3? At index equal to 1, it is 3 and 7. So in this case 4 is not valid. Why 4? Because the array itself is increasing. Before 3, 4 won't be there. So this is 2 again. Now what I will try to do is I equal to 2 and j equal to 3. If I let me clear it out. I equal to 2 and j was 3 initially, which is 7. So at I equal to 2, the value is 4. At j equal to 3, the value is 7. If I want to figure out the subsequence ending at this, what can be the possible value at this? 7 minus 4, which is 3. Now I will try to see, is there any subsequence ending with 3 and 4? Because 7 can easily be attached after this. And where I can find this value? 3 and 4. 3 is at this position. What position? 3 is at index 1 and 4 is at index 2. Index 1 and 2. 1 and 2. 1 and 2 means this value. There is already a subsequence ending at 4. Subsequence ending at 4 is 3, 4. After this, I can easily attach 7. So 3, 4, 7 can be the new subsequence at index I equal to 2 and j equal to 3. I equal to 2, j equal to 3. It means 3. 3 I can attach here. Now let's come to my last possibility. The last possibility is j is equal to 4. J is equal to 4 and the value at 4 is 11. In this case, value at I will go from 0 to 3, less than 4, less than j. So when it is 0, it means the element is 2 and 11 I want to attach after it. So if I have to attach 11 after 2, previous element should be 9. So 9 won't be in the array because it is greater than 2. The array is increasing. So in this case, directly tell that okay, this is 2, because we can't have any element before 2. When I equal to 1, I have 3 at this position. 3 and then 11, and at this position 8. No, this is not possible. Apply 2 here. Only 3 and 11. I equal to 2. In this case, 4 is the value at I, and j is 11. In this case, if I have to get one element at this position, that should be 7, and 7 is greater than 4. This is impossible to have because array elements are increasing in nature, already given. So only 2 size can be achieved. If I is equal to 3, that is 7 and 11. I will try to see if I have to use 11 after 7. The previous element should be 11 minus 7, which is 4. So whether 4 is present in the array? Yes, 4 is present in the array at index 2. 4 is present at index 2 and 7 is present at index 3. Okay. Now I will try to see what is the longest Fibonacci subsequence ending at 2 and 3. Longest Fibonacci subsequence ending at 2 and 3. What is that value? That is 3. Longest Fibonacci subsequence ending at 4 and 7 is 3. If I am attaching 11 after it, it will become 3 plus 1, which is 4. So 4 is the value, and at the end we have to return 4. Yeah. So 4 will become my answer. So in this way you have to fill the table. So if we discuss about the time and space complexity, what is the time? Time will be n square and space will also be n square in this case. But see, we will also require some space to know. Here at this position I am having 7 and 11, but I somehow want the index of 4. What is 4? The current item minus previous item. This will give me previous to previous item, previous to previous value. And what is the index of this previous to previous value? That I can get from a map which is holding value with index. This value is previous to previous, index I can get easily from this map. So this map is also been into the picture. Okay, now let's have a look on the bottom-up approach and the other approaches as well. In this case, if you have a look on the code, I'm having current element, and then current element I will maintaining a map which is having value index map, value, current value, and the current index. Current element I'm having, previous element I'm having. I want to know the previous to previous element. Previous to previous element I can easily figure out array of current minus array of previous. And the index of previous to previous element I can get from a map, right? Now I have to check one condition. See whether the previous to previous element exists or not. If it does not exist, it means that definitely there are only current and previous element in the subsequence, right? If it do exist, right? If it do exist, then the value should be less than the previous element. It should be in the increasing order because the array itself is the increasing order, right? And yeah, this is the formula, and in the end, whatever is the maximum length we have captured so far while filling out the table, we can return that. If the length is 2, we don't have to return anything. We will return the length only if it is more than 2. Yeah, this is the code, and I have also written a recursion code, and there is memorization as well, so you can easily check out this code as well. This is recursion, memorization, and bottom up. So bottom up is the code I'm going to submit. it got submitted successfully. If you have any doubt, you can comment down below, or you can discuss in the Discord community. You find the link in the description below. Okay guys, bye bye.